my dear students. How are you all? I hope you all had a great day so far. So, today we are going to discuss about the topic Newton's second law of motion. So, if you want to know more about the Newton's first law of motion, you can check out the previous video. Okay? So, today we are going to discuss about the momentum and the second law of motion. So, all of you can take out your notebook so that you can note down the important points. And let's start today's session. So, what is momentum? So, here, see, this child is standing like in between the road. In this picture you can see, which is not so good thing. Please don't do this thing, okay? So this child is standing in between the road. From this direction a cycle is coming, and from this direction a truck is coming, right? First of all, standing in between the road, it's very dangerous, so you should never try this. So can you tell me, if each of this cycle or the truck, okay, let's say cycle, the option A, and truck, the option B, is going to hit the child, who is going to, which one is going to, which one is more dangerous for the child? Can you tell me? So truck is more dangerous, right? Truck is going to like cause a lot of injuries, and like it's more dangerous. If the cycle is going to hit the child, that is not so dangerous, right? So can you tell me what is the reason behind this? So truck is like huge, it's very heavy. Cycle is very lightweight, right? It's not going to hit so hard. But if truck is going to hit, so it's going to cause a lots of injuries, right? So what is momentum here? You can see. So if a heavy object is hitting somebody, so that is causing a lot of damage, right? If a light object is hitting somebody, that is not causing that much damage. So what is the difference? So basically, here you can see it is about basically about the momentum. Okay, so if a heavy object is coming, so it has more mass. So more the mass, it is increasing the momentum. All right. And if there is a light object, it is decreasing the momentum. Momentum is basically the impact produced by the object. That impact. So like if a truck is hitting somebody, it has more impact. Maybe the speed of the truck is slower than the speed of any scooter or bike, but still, as it has a like more mass, it has more impact. So it's the momentum. Clear? Now, this was one of the example. Now, another example we can take like from the bullets. Okay, so even the bullet is very small. You know that like bullet is, it's not like huge like a truck, right? Bullet is very small. So it has less mass. So still the bullet has more impact. Why so? Because the velocity of the bullet is so high. Okay, so that's why it has, again it has more impact. So just mass is not the case, even momentum is depending on the velocity. So both momentum is directly proportional to mass and velocity of the object. Even the mass is smaller, mass is very small, but the velocity is big, then also it will having more impact. And if the mass is big, velocity is small, still it will be having more impact. Okay, so momentum is directly proportional to the mass and the velocity. So momentum increases with increase in either mass or the velocity. So this point is very important. You can note it down. So this means if a lighter and a heavier object is moving with same velocity, then heavier object will be having more momentum than the lighter one. And if the small object is moving with a greater velocity, it has tremendous momentum, and because of that momentum, it can harm an object more severely. It will be more dangerous. Okay. Another example we can take, a person gets injured in case of hitting by object such as stone, pebbles or anything because of it is having more momentum. Okay, so someone is throwing stone at you. It is having more momentum, that's why it is hitting you more. But if someone is just throwing any, notebook on you, like kids do in your school, your friends also used to do, like, hit you with a notebook or book, right? So don't hurt so much because it has less momentum. A person getting injured severely will hit by moving vehicle because of the momentum of vehicle due to mass and velocity. Okay, so to understand this very clearly, let's do watch this video.
Baseball. Momentum is inertia in motion. A lot of momentum means a lot of oomph. An even better way to describe momentum is as the product of mass times velocity. This means that if something is moving, there are two ways to affect its momentum. One, there's the mass. You know, for the same speed, a massive truck has so much more momentum than a mosquito. And two, look at the velocity. A baseball thrown gently by a kid will be easy to catch. That same baseball, thrown at 100 miles per hour, might knock you over. So a tiny bullet at a high speed has a lot of momentum. Wear a bullet vest and it'll still knock you over. An oil tanker creeping along at only a few miles per hour also has a lot of momentum, not by virtue of its speed, but by virtue of its great mass. Because it has so much momentum, so much inertia in motion, the tanker can't just pull into the dock. Rather, it's greeted by powerful tugboats that help to manage its maneuvering. A fast-flying tiny bullet and a creeping massive oil tanker are both difficult to stop. Both have a lot of oomph, that is, a lot of inertia in motion, which you now know to be what we call momentum. Good energy.
All right, so I hope that this is clear to you. Let's solve a few questions regarding this topic. So first question is, what will be the momentum of a stone having mass of 10 kg when it is thrown with a velocity of 2 meter per second? So you can pause this video over here and try to solve this. Formula for momentum is P is equals to mv, right? So mass is given as 10 kg, v given as 2 meter per second. It's very easy, just calculate this. 10 times 2, that is 20 kg meter per second. So this will be the unit for momentum. Okay, let's solve one more question. So calculate the momentum of a bullet of 25 grams when it is fired from a gun with a velocity of 100 meter per second. So again, here you can see velocity is given as 100 meter per second. Mass is given in grams. So what you have to do now? Convert it to kg. Okay. So convert this mass into kg. So this is the mass. So 2.5 kg meter per second. This will be the answer. Alright. So this is for the momentum. Now let's move on to the Newton's second law of motion. So the second law of motion says that the rate of change of this momentum of an object is directly proportional to the applied unbalanced force in the direction of the force. Alright, so basically when you are just applying a force, what happens? The unbalanced force is causing a motion, right? Balanced force do not cause any motion. Unbalanced force cause the motion. So when you are applying an unbalanced force, the object starts to move, correct? Now, when the object is moving, few object can move like if the mass of the object is more, you have to apply more amount of force, but if the mass of the object is less, you have to apply less amount of force, correct? So the rate of change of momentum, here one more comes thing, the change of momentum. So the speed of the object is changing, right? At first it was at rest. Now as you are applying the force, velocity is changing. Now first it was 0 meter per second, it was at rest. Now as you are applying force, it is moving. So it has maybe some velocity, maybe 2 meter per second is the velocity, right? So it's the initial velocity and this is the final velocity. So acceleration, there is a acceleration, right? So that is the change in the like acceleration is happening, right? So what is basically the change of momentum will be? So momentum is mv. This is the formula for momentum, correct? And v is velocity here, but the velocity is changing, right? So let's see the formula, the derivation. So F is equals to mv1 minus m1 v1 minus m0 v0, right? This is the initial. You can just write initial as u also, all right? So final minus initial, because all right, so because that's the change of momentum, okay? Momentum is p is equals to mv, all right? Now this is the velocity, this is changing. So final, there is one initial velocity and there is one final velocity. So p is equals to mu mv final minus initial minus mu, okay? And this is the change of momentum with time, so there will be time also, t1 minus t0, all right? So here you can see, if I take the mass as common, there will be u v minus u upon t, right? Now what is v minus u upon t? V minus u upon t is acceleration only, correct? So if the momentum is changing, that means there is an acceleration is developing, okay? So we get the final formula, like force is equals to mass into acceleration. F is equals to ma, a very famous formula for second law of motion, okay? This is net force, this is the net force, okay? So from this, or I can write it like this also, m is equals to f net, sorry, A is equals to F net upon A, M. A is equals to F net upon M. I can write it like this, no? A is equals to F net upon M. Correct? So here you can see the acceleration is depending on the force. It is directly proportional to the force. So if you apply more force, the acceleration will be more, because it is increasing the velocity of the object, right? And acceleration is inversely proportional to the mass of the object. So if the mass of the object is more, acceleration will be less, because then again you need to apply more amount of force if the mass is more, right? So acceleration will be less. So for example, you have one table, okay, very heavy table, and another you have a very lightweight stool. So table mass is heavier, you know, mass is more and as compared to the stool. So you when you are applying same amount of force, suppose you are applying 5 newton of force in both, so the stool will move like more quickly because it has less mass, so acceleration will be more. But for the table, you are applying 5 Newton force only, so the acceleration will be less, right? But now, if you are applying more force, here you can see, if you are just considering like there are two tables having same mass only. Now in one of the table, you are applying more force and in another table you are applying less force. So which one is going to move? Both are having same mass. So basically the table in which you are applying more force, that is going to move faster. right? So mass we are considering here as same. So from this you can see that the force and the mass is not like it is not dependent. Basically the acceleration is depending on the force and the mass of the object. Okay, so from this formula maybe there is some misunderstanding can create, because it can shows that for mass and acceleration is depending on the force is depending on the mass and the acceleration, but basically what is happening, acceleration is depending on the force and the mass of the object also. Okay, so that's the Newton's second law of motion. The rate of change of momentum of the object is proportional. Rate of change of momentum. All right. So that is the like acceleration which is happening. The rate of change of momentum is directly proportional to the force. I hope this is clear to you. Let's watch this video for better clarification.
Second law of motion says that the amount of force applied to an object affects its speed. For example, when Tony's car breaks down, he'll need to push it. The more force he applies, the faster the car will move. But this law has a second part too. The speed or acceleration of an object also depends on its mass, whether it's lightweight or heavier. If Tony pushes his bicycle with the same force he used to push the car, the bike moves faster because it has a lighter mass. There are three elements at play here: force, acceleration, and mass. Mass is the amount of material an object is made of. The weight of an object depends on its mass. In Tony's case, his car has more steel, glass, and aluminum, so it's heavier and more difficult to move than something lightweight, like his bike. Let's take another example: shopping carts. Whatever the cart is made out of, metal or plastic, makes up its mass. When you apply force to an empty cart, it accelerates rather quickly. That's because the mass of an empty cart is lower than a full one. It's easy to push at first, but as you add your favorite foods, the cart slowly becomes heavier. You'll need to apply more force in order to keep it moving forward, since the total mass of the cart grows with each item added. Just remember, the amount of force needed depends on how fast you want an object to move, as well as its mass.
All right, so that's about the Newton's second law of motion. I hope this is clear to all of you. So please do watch the other videos also, previous videos, for a better clarification of this topic. Okay. In the next class, we are going to cover the Newton's third law of motion. Okay. And if you do like this video, hit the like button, subscribe to my channel, and share this with your friends also. Okay. If you have further queries, you can put those questions in the comment box. So I will definitely try to solve your queries. All right. So take care. Have a nice day. Bye bye, all of you.